Okay, metamorphic rock. What is metamorphic rock? It is formed by because of pressure and temperature onto the igneous rock or sedimentary rock. So when igneous or sedimentary rock, they are subjected to high pressure and temperature condition. They convert to another rock, what we call metamorphic rock. Because the rock consists of different minerals. So mineral at a particular temperature pressure upon the they can withstand the they can be able to keep their structure up to a particular pressure and temperature condition. After that, they will change to another form. They cannot withstand, suppose ki at high temperature pressure condition, they will convert to another structure, to another mineral, to another rock, you can see. It's called metamorphic or metamorphism. So metamorphism would change of mineral and geological texture in pre-existing rock, protolith khanti, without the protolith melting into liquid magma. Again, essentially in solid state change. Metamorphism normally occur when igneous or sedimentary rock they are subjected to pressure temperature condition, they will convert to another rock, what we call metamorphic rock. But the process should be essentially in solid state. Solid state meaning is the rock should not melt. Rock should not melt. That doesn't mean that there is no liquid involved. There's the liquid involved in case of metamorphism, what we call metasomatism. So if you say a metamorphism occur essentially in solid state, that means the rock will not melt. If rock will melt during metamorphism, then it can produce a hybrid rock. Ligmatite. So essentially solid state meaning is the rock should not melt. Will not melt into a magma. But the liquid will involve what we call chemical active fluid, so that can change the rock. That can change the rock or change the composition of the rock. So metamorphic rocks that form by temperature, pressure, and we can add one chemical active fluid. So when the rock subjected to temperature, pressure, and chemical active fluid, they are converted to metamorphic rock. So metamorphic rock, if you subject more pressure or temperature or progressive temperature pressure condition, then it will then further change to different grade of rock, low grade, high grade, medium grade. So that you will study in progressive metamorphism how with progressive temperature pressure condition the metamorphic rocks grade changes. So metamorphic rock contain minerals stable at temperature pressure condition of metamorphism. If the change temperature pressure condition will change, then the new mineral will appear or some mineral will disappear. So, so new mineral they will be adjusted to the new pressure and temperature condition. That's how the grade will change. So these temperature, pressure, and chemical active fluid. Those are called as your agents of metamorphosis. Those are called as your agents of metamorphosis. First, we'll study about temperature. So it is the most important. The heat or temperature. Same thing in case of high temperature, high pressure condition, mineral will not stable. So each mineral within a rock they are stable at a particular state of temperature pressure condition. If that exceeds, then they will change into new mineral or their configuration or structure will change to a new form. So first agent is your heat or you can say temperature. It is the most important agent. So as we go down beneath the surface, the gradient will increase. In the upper coastal region, you will get from 25 to 30 degree per kilometer. That is gradient. That will increase the temperature. So as we go down, or as we within the subsurface region, the temperature increases so that different mineral will convert it to metamorphic rock. A different rock will convert it to metamorphic rock because they cannot withstand the temperature and pressure condition that is changing with depth. So with more depth and with increase in burial or with increase in tumor overburden, as the sediments that is deposited, they will convert it to sedimentary rock. That is called as your diagenesis. If temperature exceeds the diagenesis condition, then metamorphism will start. So that's why we say after diagenesis, metamorphism will start. So the metamorphism will begins approximately at 150 to 200 degrees centigrade, but it is not okay, for all type of rock or all type of mineral involved because this is the least. Metamorphism can start at a 400 500 degree temperature also, so that depends upon what type of mineral is involved within the rock. If I saying the low grade mineral like more sedimentary rock clay mineral or other low temperature mineral, they can start by converting at 150 or 200 degrees centigrade. But if you are considering any mafic or ultramafic mineral, ultrabasic mineral or basic mineral, so those rocks that containing these minerals, they will convert to metamorphic rock at higher temperature. So that depends upon the composition of the rock. At what temperature their metamorphism will, or at what temperature they will convert to metamorphic. So the least is 150 to 200 degrees centigrade, or we say 200 degrees centigrade, or after diagenesis. And it will end at also that depends upon the composition of the rock, where it will completely melt or either it will partially melt to produce a hybrid rock that is called magma type. So onset will 150 to 200 and for it will end at approximately 800 to 1000 degrees centigrade, but that depends upon the composition. Again, that depends upon the composition. Which if it is acidic rock, then it will melt at low temperature. If it is a basic or ultramafic rock, it will melt at higher temperature. With increasing temperature also, decrystallization occur. So mineral that present, they will again crystallize. And as the temperature increases, for metamorphic rock, sometimes it keeps the protolith texture. Protolith means protolith. Protolith is a either igneous or sedimentary rock, which converted to metamorphic rock. So always a metamorphic rock has a protolith that form from a igneous and sedimentary rock. So sometimes during metamorphism, protoliths textures are carried through the metamorphic rock. So that means suppose ki a porphyritic texture there, so porphyritic texture cannot be destroyed during the metamorphism. It not completely destroyed during metamorphism. It can be found within the metamorphic rock after formation. Suppose we are taking an example, which is porphyric granite. It converted to suppose metamorphic rock. So this is a protolith, metamorphic rock. So during for initial stage of metamorphism, this is a granite crystal is in high grade condition. So during initial stage, in the metamorphic condition of granite, you will find porphyritic texture. So as the temperature or pressure increases, this texture will destroy. So as the temperature increases, the proteolytic texture will gradually destroy. But at low grade condition, the proteolytic texture will preserve. Protein texture टा तुम low grade condition में preserve होगा जब तुम temperature increase करेगा तो that will gradually destroy. This is the temperature. Then pressure. So it is because of tomorrow weight of the rock, that is lithostatic pressure, or caused by tomorrow directed pressure or by tectonic activity. So during tectonic activity, pressure will increase and it can change the mineral into different structure or different rock. That is your simple metamorphism. When igneous or sedimentary rock, when they will subject it to pressure condition, they will convert it to metamorphic rock. So same thing, can write down similar thing about tomorrow temperature condition. But in case of temperature, if only temperature is there, so there will be no pressure. So you'll find mostly non-foliated texture. If there is a high pressure condition or only pressure dominant condition, then you will get foliated texture. That is the thing. So pressure thing we'll discuss mostly in dynamic metamorphism, where metamorphic dominantly occur because of pressurized condition. So you can also add here the isotropic stress, anisotropic stress. Okay. खाली प्रेशर कंडीशन तुम शीघ्र को ऐड कर पारो हला हाइड्रोस्टैटिक स्ट्रेस रिक्वायर्ड अछि ताले ऐड करो नॉल नहीं तो केमिकल एक्टिव फ्लूइड so chemical active fluid it has very strong influence on metamorphic rock because if any metamorphic rock that generally formed because of pressure and temperature condition or you can say that they are formed by deformation action. Due to deformation, they can produce fracture or joints, or they can even contain pore spaces. Where mostly in case of metamorphic rock, as they are produced by pressure condition, so mostly pore spaces are destroyed during that process or during that pressurized condition. But some cases, if they are containing fracture or pore spaces, then for a mineral rich solution, mineral mineral rich solution, or we can say hydrothermal solution. What is hydrothermal solution? These are hot water containing mineral. These are hot water containing mineral or hot water mineral rich. So they can accumulate within the pore spaces of the rock. They can accumulate within the pore spaces of the rock. So then two things will happen. One, either they will precipitate in that pore spaces. Pore spaces will precipitate it, so that is pore spaces will completely close. Suppose there is a pore spaces within a rock. So these hydrothermal solutions they will accumulate it. They can accumulate here. So when they will accumulate here, all their mineral content can precipitate there. Or they if this hydrothermal solution containing reactive mineral or reactive element, so they can react with the wall rock of the pore spaces or fracture. So when they will react with the pore spaces, wall of the pore spaces or fracture, there will be ion exchange reaction, so that so gradually the composition of the rock will change. So that is also a type of metamorphism where metamorphism involved with a change in composition. So mostly the more hydrothermal solutions are there for chemical active fluid and all other the water that is expelled from igneous reaction. So with that water expelled from the magma, all can be mineral rich. So they can accumulate within the rock, or they can convert the rock or the composition because by this ion exchange reaction from the volcano. So this water that helps to move the ions through the solid rock, allowing the rock to decrystallize into more stable structure. It also helps in ion exchange between the mineral, which is responsible for the formation of completely different minerals. So जोटा कि तुम्हारा because of तुम्हारा ion exchange होଉଛି. So मन रखो कि during तुम्हारा hydrothermal solution when it will accumulate or accumulate within the pore spaces or fracture of the rock, there are two things will happen: either that will precipitate or completely fill the that will fill the pore spaces or fracture, or it can do a ion exchange reaction where it will change the composition of the rock. So among these agents, temperature is probably most dominant, most you can say the most uh, causes for the metamorphism. Correct? There is the most common causes. Temperature is the most common cause. So always temperature is associated with metamorphism. So pressure may be least in some cases, but temperature is always associated. It is the most common. And remember, as the grade will increase, so grade of the metamorphism, the grade of the metamorphism always determined on the basis of temperature. Always determined by temperature condition. That means the more the temperature, the more the grade. So if you are saying something is high temperature, high pressure, then obviously it is high grade. High temperature, low pressure, it is also high grade. But high pressure, low temperature, it is low grade. So always the grade term is associated with temperature term. That means more the temperature, more the grade. So we cannot determine the grade on the basis of pressure. Obviously, they are high pressure condition along with high temperature can be considered as high grade. But high pressure along with low temperature will be low grade. And as the grade increases, remember the grain size of the metamorphic rock will increase. The grade increase करेगा, the grain size will increase with grade. And if there is temperature is a dominant agent, so that means कि there are always relic texture. Relic texture means texture will preserve after metamorphosis. But in case of pressure condition where pressure is dominant, then it will cross the rock. It will destroy the texture. It will destroy the texture because during tomorrow dynamic metamorphism where pressure is dominant, there is crossing, grinding, all these things will happen, which will destroy the totally texture. Always. But in case of initial stage of you can say at a low grade condition during temperature dominant metamorphism, texture will preserve. But as the temperature increases, as the grade increases, then texture will destroy. But initial stage it will always remain more of the relic texture will be there always. Then temperature also helps for reactions because where we are saying a mineral is converting or suppose a igneous rock is subjected to temperature pressure condition, now it is converted to metamorphic rock. That always happens through reactions. A mineral will change its structure or it will convert to another mineral that always associated with whatever reactions. So reactions always depend upon temperature. So that's why temperature also it plays a dominant role for the reactions at what temperature, or it is the temperature is always giving that suitability for the reactions. So with increase in temperature, there will be always two types of reactions. Commonly, you will find there is devolatilization. Devolatilization and convert divided into two types: decarbonation, dehydration. The temperature dominant condition normal. So here आम्ही तुला कहू शकतो की suppose we are the giving temperature to a rock or mineral, so it will reach to that a state where it will not withstand that temperature pressure condition. So it will change. So it will change via reactions. It will change via reactions. So where the temperature is also a dominant thing. Because of that suitability that is given by temperature. To when the reaction will occur, whether it is decarbonation or dehydration. Because as the temperature increases, obviously there will be dehydration. Understood? What are the types of metamorphism? Then boreal metamorphism, ocean floor metamorphism. Huh? So you can also add like the impact metamorphism, or pyrometamorphism, temperature condition locally. And also smaller division, but mostly the major divisions are thermal, dynamic, dynamothermal. Thermal particular contact metamorphism. The dynamic it is pressure dominant, dynamothermal both pressure and temperature dominant, but it is called regional metamorphism. Then boreal it is a low grade metamorphism. Then ocean floor it is because of ion exchange. And there is a separate thing that is metasomatism. Last we'll see what is contact metamorphism. So where temperature is dominant, contact metamorphism कौन सा temperature dominant है. So it is formed where there is least pressure zone. So contact metamorphism form at shallow depth because the pressure is less here. So it is formed at shallow depths at high temperature condition. So that will be provided by igneous intrusion. So around igneous intrusion you will find contact metamorphism. So contact metamorphism is actually developed where hot magma intrudes relatively cold upper crustal region. So there are three zones actually on the basis of depth. One is AP zone, one is mesozone, another kata zone. AP is on upper part, then mesozone, then kata zone. So kata zone, it is at greater depth. Kata zone at greater depth, the temperature is too high, so the rock will melt. And mesozone and epizone. So if we divide three zones like this, this is a epi zone. This is epi zone, mesozone, kata zone. So mostly all the contact metamorphism, it is mostly abundant in mesozone. It is mostly abundant in mesozone. Here contact metamorphism is abundant. So why contact metamorphism is most abundant in mesozone? Because if I find rock in catazone, so they have already high melting temperature. So intrusion cannot convert them to a metamorphic because in catazone they are at pressurized condition and they are high melting temperature. Epizone their melting temperature they are very less କହିପାରିବ କ'ଣ? They are very less temperature and they are very cooler rock. So intrusion it cannot increase the temperature to such level so that they will convert to metamorphic rock. And also the temperature of the intrusion also decreases upward. So the mesozone is more suitable because here the rock they have uh, that much of temperature so that an igneous intrusion can easily convert them into metamorphic rock. So that's why most abundantly you'll find metamorphic contact metamorphic rock in for mesozone. So that is in the intermediate depth mesozone where the plutons cool more slowly and thus maintain metamorphic temperature for longer time. In that case, in mesozone, the rock is also suitable so that they can easily convert to metamorphic rock, and also at lesser depths, it will cool more easily. Igneous intrusion. Let's suppose that epizone. When it will reach to epizone, most of the temperature it loses during its path. But in case of tomorrow mesozone, that is more suitable because the metamorphic temperature will will maintain there, and protons will cool slowly. And also the rock within the mesozone they are easily susceptible to changes, so that they can change to metamorphic rock. So that's why in that region the metamorphic aureoles will be more, or you can say so mesozone which is situated that is more susceptible to changes, so that in mesozone wider or greater range of metamorphism contact metamorphism can be found. So when an igneous intrusion they affect the surrounding country rock, so along with igneous intrusion and the affected rock, together they are called as metamorphic aureoles. Metamorphic aureoles. So it is like this. This is the igneous intrusion. So now it is affecting the surrounding country rock. So around this igneous intrusion, you will find metamorphic rock. So near the intrusion, you will find rock having highest grade, and as we go away from the intrusion, the grade will decrease. Also temperature. Similarly, this complete thing is called as a metamorphic aureoles. So suppose there is igneous intrusion here. Now it is affecting up to this point, and after that you will get on metamorphosed rock. So at the periphery, we will get low grade rock, or for this you can say this is the lowest grade rock at the periphery, and near the rock igneous intrusion you will get highest grade rock. So in case of contact metamorphism, there is for more temperature, so there is always devolatilization reaction. That is, you always expel fluids. So that's why contact metamorphism is also commonly affected by metasomatism. Because with temperature, there is always devolatilization reaction, dehydration, decarbonation. So they will expel fluids. Sometimes these fluids are in silica-rich water or igneous intrusion. They will affect the calcareous rock ratio. So when they will affect the calcareous rock region, they will produce a special type of rock, what is called star, or you can say, or the name is stactites. Mostly acidic rock, or sometimes our basic magma is also associated. So here texture commonly preserved because there is very little pressure condition, so there is no pressure for deformation. And the pyrometamorphism is a minor type of contact metamorphism. It is characterized by very high temperature but very low pressure. So it is a local metamorphism. So it is generated by volcanic or sub-volcanic rock. That is called pyrometamorphism. So in case of contact metamorphism, are there very little temperature, little pressure, so it generally produces granular rock. Granular produces granular texture. So Hornfels, or you can say granoplastic texture. So these are texture that is associated mostly in case of metamorphic rock. So mostly metamorphic rock produces the granular texture. So that doesn't mean that it doesn't contain any elongate minerals. So the elongate mineral is produced, not that only always granular mineral. Granular side you also find elongate or platy minerals. You know like whether you will find elongate or platy minerals in contact metamorphic condition or not. But the thing that because there is no pressure condition, they will not form a proper fabric. They will not foliated texture. They will not form a foliated texture. There is elongate mineral, pretty mineral, all type of minerals, all type of shape of minerals you will find, but they will be always in a random arrangement. They will not show a proper arrangement. When pressure will apply, if you apply pressure, then elongate mineral will produce a proper fabric, a proper arrangement. Suppose they will align themselves or they will form a parallel alignment. That is called as a foliated texture. So always remember the elongate minerals within a rock doesn't mean that it is a foliated texture. Doesn't mean that it is a foliation or lineage. Always remember the elongate mineral or pretty minerals with a proper fabric. Uh, With a proper fabric is called as a foliation or lineage. The random fabric it is simple. You can say other type of texture, you can granular texture or other type of texture. So contact metamorphism generally when the granular rock consists of finer grain. Those are called as hornfels. Those are called as hornfels. So hornfels is similar to more granular type of texture, but it is the consists of more finer grain and it has a protoliths always clay. Hornfels of protoliths clay because it consists of finer grain. So clay type of rock when subjected to contact metamorphism they will produce hornfels. So it is most common. So that's why we called it as hornfelsic texture. What is it called? Hornfelsic texture. It is the characteristic texture of a contact metamorphic rock. Understood? So you can take any igneous intrusion as an example: batholith, shale, dike, locolith, laccolith. All are igneous intrusion. So intrusive structure around intrusive structure you will always find contact metamorphism. We go dynamic metamorphism or we say cataclysmic metamorphism. So pressure is the dominant agent here. In case of the dynamic metamorphism, dominant agent is pressure. So obviously it will form at high pressure condition where the rock subjected to high pressure condition. So if it is a brittle rock, then it will break. If a ductile rock, it will deform like a plastic thing or ductile thing. So because of tomorrow pressure condition, so that's why it is mostly localized in case of tomorrow tectonic active region. So where there is fault or where there is a mountain building process, where there is collision setting, all this kind of condition you will find dynamic or regional. So that's why the dynamic metamorphism is generally found in fault zone during for a non-uniform stress or anisotropic stress. I suppose sigma 1, sigma 2, sigma 3 there. So if sigma 1 is greater, there is a normal fault or other type of thing, sigma 2, sigma 3. So due to tomorrow faulting or due to tomorrow fracture or due to breaking of rock by tomorrow pressure condition, they will produce a type of metamorphic condition, what we call dynamic or cataclysmic. So dynamic metamorphism occur over a very relative short time because tomorrow the faulting event it is not continuous. It is not. It is periodic. So for a shorter time it will move, then it will stop. Then again after some time with increasing temperature or increasing pressure condition, then again it will reactivate. যেতে reactivate হবে সেটা move করিব, then when it will move it will cross rock within them. So দুইটা block যেতে move করিব, so two block will move, they will cross the rock in between them, so that will convert them to another rock, that is also metamorphic rock, that will form by dynamic metamorphism. So during the metamorphism in pressurized condition along the fault zone, you will find different type of rock. So and with depth, the strength of the rock will increase. Suppose you have a rock at 4 to 10 kilometer, the strength of the rock will be greater than the same rock you will find at the surface will be less. Suppose you are finding a rock, suppose A at depth 4 to 10 kilometer, and this depth, and this same rock is found at the surface. So the rock at the depth will have more strength than the rock at the surface. So as we go down, the strength of the rock will increase. So it requires more stress to break. So with depth, gradually more strength increases, and with depth also temperature increases. With depth, temperature increases. As temperature will increase, then rock will convert from brittle to ductile. Brittle to ductile. So when it is brittle, it will break. It will break. When it is ductile, it will just deform without breaking. To behave like plastic metal. So with depth up to, you can say, if 15 kilometer, up to 15 kilometer, you will get brittle deformation, where tomorrow fault will be dominant. At 15 kilometer, there will be a transition. So brittle metal will convert to ductile metal, what we call BDT, brittle ductile transition. So after that, when it rock converted to ductile metal, the strength will again decrease. So accordingly, during a fault zone where there is more pressure, you'll find different type of rock that is produced by dynamic metamorphism or cataclysmic metamorphism, depending upon the breaking condition, whether it is a ductile or brittle. So at the upper part, during the crossing on grinding, it will produce more matrix than the lower part, where that is more ductile deformation. So up to this point, you can say, up to this depth, we are getting brittle type of rock. Up to that, we are getting ductile type of rock. So this part or below that, you can consider this as shear zone, but this part is considered fault zone. The myelonate part is considered as shear zone, and this part is considered as a fault zone. And this is the BDT, where temperature is around 350 degrees centigrade and depth is 15 kilometers. That is your brittle ductile transition zone. So what type of rock that is produced along this fault zone where dynamic metamorphism occurred? So these are the different types of rock you can find. Cataclysmic, pseudotrachite, myelonite, like that type of rock we'll find with depth, brittle to ductile. classify them like this. So rock that found along the dynamic metamorphic condition. So rock with primary cohesion, without primary cohesion, or with primary cohesion. So without primary cohesion, we have fault breccia, fault gauge. Difference is matrix percentage. So fault gauge has more matrix than fault breccia. So fault gauge has more than 70% matrix. Matrix means the finer grain. So it is produced because of the crossing of two blocks. The non-foliated protein with cohesion. There are two types of non-foliated, foliated, and glassy. Non-foliated microbreccia cataclysite. So cataclysite is a rock that is produced dynamic at a dynamic condition. That's why the name is cataclystic metamorphism. So it has high matrix percentage, but it has so there is a cohesion between sedimentary grain. Sorry, metamorphic rock grains. Then foliated is more a ductile condition. So there are two types of blastomyelonite condition. One is a myelonite. So myelonite further divided into three types on the basis of matrix percentage. Proto, ultra, myelonite. Ultramyelonite has more matrix percentage. Blastomyelonite it is significantly formed during the dynamic metamorphic condition. So that's why the prefix blasto is used. Then pseudotrachite is a type of rock which is brittle. It is brittle. So it has more matrix percentage, we can say. It has more glassy, or more finer matrix percentage. So generally, it is formed during more earthquake condition. Produced during earthquake condition. So among all these rocks, where myelonite is only the ductile type of rock, and all other are brittle type. Fault rocks, fault breccia, microbreccia, cataclysite, pseudotrachite, all are brittle except our myelonate or our protomyelonate, ultramyelonate, blastomyelonate, all are you know, ductile and all other are brittle. What we call regional metamorphism. Dynamothermal metamorphism generally it is associated with both tomorrow high pressure and temperature condition. So generally tomorrow found in orogenic well condition. Like a high temperature pressure condition is dominant there. So sometimes we can call it as orogenic metamorphism. So like it generally found in convergent plate margin. So it is generally produced in case of the dynamic metamorphic condition because of high pressure it will produce foliated texture. It will produce foliated texture in dynamic condition. So where because of pressure rocks are all the elegant minerals they can arrange themselves in a particular fabric or particular fashion that will produce your foliated texture. In case of dynamic metamorphism it produces a type of texture which is called as gneiss, which is the characteristic texture of a dynamic metamorphism. Also during dynamic metamorphic condition, because there are two types of metamorphic condition, we also found overprinting texture. Today we texture discuss kariba overprinting texture. Where there is a schistose texture, or there is a granular texture, and again there is another type of metamorphic condition will set it will produce another type of texture. So mostly it is associated with convergent plate boundary. Common regional condition. Where both temperature pressures are dominant is it. Next we have boreal metamorphism. Boreal metamorphism, it is a type of metamorphism where there is low pressure and low temperature condition. This is a low grade metamorphism. So the main characteristic of this boreal metamorphism is texture, structure of the protolith preserves after metamorphism. So after metamorphism, because it's very low grade or low temperature pressure condition, the protolith will preserve its temperature, texture and structure after metamorphism. Generally, it is found in basin region. You can say found in Forar basin, Packer basin, Foreland basin. Then you can find in Trench region. So all this basinal region will find boreal metamorphism. Next, there is a metamorphism called the ocean floor metamorphism. So it is similar to hydrothermal alteration that occur during ion exchange of basic magma with ocean water. So that will produce black smoke or white smoke or different type of deposition at the mid-oceanic region. So that side is also called as mid-oceanic region metamorphism. Or simple during metamorphism or simple due to metasomatic alteration. Simple due to